Today I'll talk about Gauss Jacobi method. So here we are going to solve system of linear equation by using Gauss Jacobi method. There are two methods we can use for solving system of linear equation by iterative method. One method is Gauss Jacobi, another is Gauss Seidel method. So here I am using Gauss Jacobi method. So Gauss here system of linear equations are 10x plus 2y plus z is equal to 9. So this is the equation number 1, and then x plus 10y minus z is equal to minus 22. So that is equation number 2. Minus 2x plus 3y plus 10z is equal to 22. That is equation number 3. Now rearrange equation 1. So that is x is equal to 9 minus 2y minus z by 10. So that is rearrangement of equation 1. Then rearrangement of equation 2, y is equal to minus 22 minus x plus z by 10. And then rearrangement of equation 3, z is equal to 22 plus 2x minus 3y by 10. Now first to solving by using Gauss Jacobi method. So first we have to take initial guess. Initial guess here I am taking so initial guess will start from 0 0 0. X is equal to 0, x0 is equal to 0. So this is the iteration number. Y0 is equal to 0 and Z0 is equal to 0. Now we are going to start the iteration number 1. So now we are putting that, so these are the three equations. Already I rearrange, so that x is equal to 9 minus 2y minus z by 10, y and z. So now I am putting here x0, y0 and z0 value. So and getting x1. X1 is the first iteration value, x1. 9 minus 2 y0 minus z0 by 10, that is equal to 9 minus 2 into 0. Y0 is equal to 0 and z0 is equal to 0. Ultimately x1 is equal to 0.9. Then similarly y1 is equal to minus 2 22 minus x0 plus z0. X0 value is 0, z0 value is 0 by 10. Ultimately we will get minus 2.2. Similarly z1 is equal to 22 plus 2 x0 minus 3 y0 by 10. Again x0 is 0, y0 is 0. So ultimately z1 will be 2.2. So after iteration number 1, we are getting x1 is 0.9, y1 is minus 2.2 and z1 is 2.2. Now for going iteration number 2, so we are using that x1, y1 and z1 value. So here x2 will be 9 minus 2 y minus z1 by 10. So 9 minus 2 into minus 2 2.2 minus 2.2 by 10. Ultimately we will get 1.12. y2 similarly we are plugging x1 value and z1 value. So minus 22 minus 0.9 plus 2.2 by 10. So that is minus 2.07. Similarly z2 22 plus 2 into x1 minus 3 into y1 by 10. So again I'm going to plug this value. So ultimately we'll get that 3.04. After iteration number 2, we are getting x2 is equal to 1.2, y2 is equal to minus 2.07, z2 is equal to 3.04. Similarly, if we do the iteration, so we'll see after 7th iteration, so x7 is equal to 1, y7 is equal to minus 2, z7 is equal to 3.0. And iteration number 8 also we will get same result. So now here consecutive 2 iteration we are getting that nearly same result, or maybe the difference is very less, maybe 0.0001 or maybe less. So now we can say that our iteration is converged and we are getting the solution. Now solution is x is equal to 1, y is equal to minus 2 and z is equal to 3. Okay, now what is the stopping criteria? I told you. So when the two consecutive iteration values are same or maybe very less number, if you subtract like x7 minus x8, if you subtract the two iteration, that will give very less value, means less number, maybe 0.001, something like that. Then we can stop the iteration. So this is the procedure how we can solve the system of linear equation by Gauss Jacobi method. Now I'm coming Gauss Seidel method. So Gauss Jacobi method we know, and now next is Gauss Seidel method. That is very popular method. We can use Gauss Seidel method. So here example of Gauss Seidel method. solve the following system of linear equation by Gauss Seidel method. So we are taking same system of linear equation, and we are here I am using by using Gauss Seidel method to solve this system of linear equation. Now again, so rearrangement will be done. So equation 1 will be 9 minus 2y minus z by 10, y will be minus 22 minus x plus z by 10, z will be 22 plus 2x minus 3y by 10. So this is the rearrangement. Now again we are taking, means here initial guess should be x, y and z is equal to 0 0 0. So x0 is equal to 0. So again 0 0 0 is here, that subscript is actually iteration number. So at 0 iteration, so x, y and z values are 0 0 0. Now I am going to start the calculation by using Gauss Seidel method. So Gauss Jacobi method, we are using the same value, okay, and but Gauss Seidel method we will using updated value right now. Okay, so we know for this Gauss Jacobi method, so y0 and z0 we are using, and then y1, when we are calculating y1, so we are using that same old value. Okay, so old initial guess value. But for Gauss Seidel method, here Gauss Seidel method, first we have to calculate x1. So x1 we are taking y0 and z0 value. Y0 is equal to 0, z0 is equal to 0. So we are calculating 0.9. Now for next iteration, next when you are calculating next variable y1, so now here we should use the updated value of x. So that is we are putting x1 value, and z0 we don't have the updated value, so we are putting 0. Now after putting all this value, plugging all this variable value x1 and 0, so we'll get that y1 will be minus 2.29. Now for calculating z1, so for that again we are plugging the update value. Now we got x1 value, y1 value, so here we will put that updated value. Now if we put updated value and then calculate the z1, so we'll get 3.067, means we are getting faster that convergence value. Obviously we have to check that. Okay, so this is the after first iteration. So you can see, so initial guess is x0 0, y0 0 and z0 0. x1 is 0.9, y1 is minus 2.29 and z1 is 3.067. Similarly second iteration, so x2 we are using y1 and z1 value. Okay, now we'll get 1.0513. For y2 calculation, we will take update x1 value. Okay, so if we take that updated x1 value, and z1 is already that is the iteration number 1 value. So after putting all this, we can get y2 is equal to minus 1.9984. Now we are getting x2 updated x2 value and y2 value. So for when we calculate z2, so we will use that updated value. So 22 plus 2 x1 minus 3y by 10. So we will get that z2 is equal to 3.0098. So now if we do the calculation similar way, so we can see that iteration number 4 and iteration number 5, so we'll get x4 is equal to 1, y4 minus 2, x4 3, x5 again 1, y5 minus 2 and z5 3. Now here two consecutive equation that variables value are nearly same, or maybe if you subtract, if you take the difference, so that will be very small. So now we can say that we are achieved the convergence. So we can stop the iteration. Now here you can see that Gauss, earlier we saw that Gauss Jacobi, it took Gauss Jacobi, the iteration number was 8. Now here Gauss Seidel, we can see that within 5 iteration we are getting the desired convergence. Desired convergence, so you are getting. So now you can say that Gauss Seidel method give faster convergence. That's it for that Gauss Seidel and Gauss Jacobi method. Thank you.